recorded. All right, a uniform 250 Newton ladder, 12 meters long, frictionless wall, and an angle of 58 degrees. So we underline. The ladder just keeps from slipping. So wall, ladder. We make a picture with everything in it. 12 meters long, frictionless wall. I think the floor can't be frictionless, can it? No way. How could it not slide? So without looking back, who could be a force on the ladder? ABS, all else fails. You just do mg, which turns out to be 250. You put the information and draw a picture. Newtons. Anything else, girls, that you can remember from the other ladder problems? We call it FG as well. Yes. Friction from the floor goes like this. Oops. Friction from the floor has to be. And I think we just got, we got two more to go. Two more, yeah. Excuse me? Normal force. My picture's getting a little crowded here, isn't it? I think there's just one more force. F wall. F wall. Call it FW. Maybe I should have made it bigger. What are the forces acting on the bottom of the ladder? Well, the two forces aren't there. There's the normal and the friction, right? Normal and the friction, right? Bottom of the ladder. What is the coefficient of friction of the bottom of the ladder with the ground? Anybody suggest an equation we might use for friction? Flat surface. Yeah. Yeah. Okay. Uh-oh. We need the we have the normal because the up's equal to down. The normal is going to be 250, isn't it? Sum of the forces in the y direction equals 0. So your normal's got to be 250, am I right? Yes, right. Yeah. With me? So what we realize is that what we don't have is the friction. So what do we do? I think we need to do a torque problem, don't we? Because we need normal. If we get the normal, we can get the, what do we want, the coefficient of friction. Any suggestion where we might put friction force? Sorry, the axis of rotation? Yeah, let's see if that works. So then we'll have two torques. We have the weight, which we know. We have the normal. But then you got the friction, though. If we put the top, we don't know the friction, nor do we know the normal, right? Is that okay to do that? She wants to put the pivot at the top because we're allowed to put it anywhere we want to put it. But maybe, yeah, well, maybe actually, we know the normal is 250. Is that okay? What she's saying there, I think it seems like it might be a lot of work. Yeah. Yeah, if we put it at the bottom, by the way, I'm not sure if you're wrong, but if we put it at the bottom, we're down to just two torques, aren't we? And I think that what Kira will tell you that the sum of the forces in the x direction equals 0. Kira's going to probably tell you that FW equals friction, if we can get that. Yeah. See what I'm saying? We can get the friction if we get FW. So at the bottom, we eliminate two forces, which is really nice. And one of those, yeah, I think we're going to go that way. And like I said, I don't even know, Olivia, if that's wrong. Was it? I think, let's see, if we put it at the top, we don't know the friction, and we don't, we do know the normal. It just is like a little extra work. Yeah, that's right. We know the weight, you know the normal. No, I don't think what you said is wrong. I think it's less, it's more math, though, isn't it? Look into it. Maybe, like I said, I'm not sure you're wrong, but if we put on the bottom, we just have 2 torques, and that's kind of nice. You know? All right, so what is the FW when you do that? Everybody get the FW and F for the friction? So want me to do it? Ready? So the sum of the torques equals 0. Putting the pivot at the bottom. The ladder weighs 12, so it's a FW. Oh, what's the trig of sine 58 degrees times the 12-meter ladder plus, excuse me, equals the other torque. Oh, what's its angle? So that is 250 times sine of what? Well, we're saying that this torque equals that torque. So I'm doing the weight of the ladder now. Oh. Yes, it's 250 times sine. What angle do we use, girls? 232. Right, 32. Anybody not seeing that? That the base angle is 58, so that angle, seeing a right triangle in that picture, is the complement. The angle to the ladder is 32 times the weight x at the midway point, so that's 6.0 meters. And I think we got FW, and therefore we have friction. And then once we get friction, we can get the coefficient, can't we? Once we get FW, we'll know the friction, which is the sum of the force radius. Then we can get the coefficients. Lattice torque equals the wall's torque. Follow that, Eliana? They're using that bottom pivot. See the 2 torques? This torque equals that torque, right? 2 opposing torques. We know this torque. This is 32, right? It's complement of that. This is 58. That's 32. Got a little right triangle in there. And so those 2 torques have to equal each other because there's no rotation at that minimum value. There's no rotation. It's barely slipping, so it's at the limit point. And what's that? 3 significant digits? Yep. How about 0.318? Anybody get? Maybe I use 0.318. Anybody want to see me continue this? What do you get for FW? Who's got the answer for FW and therefore friction? How much is it? Yes. Correct, girls? She right? I got 79.4. You got what she got? 78.4. Okay, 78.109. Good. So you're going to get this slightly different coefficient. I wonder why I got 79.4. That's just bad math, I guess. Close. The answer should be around 0.318. So that's friction. Did you get that, Caroline, already? Yeah. What'd you get? Point what? 312. 0.312. All right. So then you just do friction equals mu times normal. You know the normal is 250. So 78.109 equals mu. It's got a little crowded. Times the normal is 250. Maybe I can clean this up because this is just a mess. Could you feed me the info? Okay, would you do that, Al? So we can see it nice. So the friction is mu times normal. Was the normal 250? Yeah. And the friction was 78.9 newtons. And you divide both sides by 250. And we're done with ladder. So we do a ladder. Got homework tonight. Do a good job. The quiz is coming up Thursday. I'll be available Wednesday. Want to meet Wednesday or Tuesday better? Which is better for you? Oh wait, what's happening with the event? Wednesday? So I can't do it. How about this next week, Tuesday? Like, this is Wednesday.